OK，大家留意啊，嚟緊呢個 session 咧會係英文去，即係 speaker 會講英文嘅。Let's start our next section now, and then this is Mr. Utkarsh, and then from Deploifai, and then I would like to pass the time for him.
Thank you. Thank you. Okay. Is my volume fine? Yeah, cool. Okay, thank you so much, everyone. Thank you for inviting me. Thank you for having me here. Today in this talk, I'm going to share a little bit about doing machine learning on the cloud. I think a lot of speakers in the past today already have talked about doing machine learning on SageMaker from fellows at AWS, and earlier in the morning from Microsoft as well. So I'm just going to talk a little bit on a different note here, where I'm going to go machine learning more sort of in a custom way, coding it out yourself. It's going to be a little hands-on, so if you have any questions in the middle as well, I'm OK to stop and explain. And then later in the talk, just talk a little bit more about how we at our company do machine learning on the cloud and how we make it quick and scalable. So a little bit of background about myself. I graduated from HKU as a computer science bachelor's student in 2020. And then since then, I've been working on a number of projects. I've been working on my own startup called ClearBot on the top left. Right? It's a robot that cleans the oceans. And a lot of my machine learning experience comes from there. And then later on, I also started working on a project with a couple of my friends called Deploifai, which is basically aimed at making machine learning for the cloud simple and scalable. Right? So if you're wondering if this talk is for you, well, if you're just getting started with Python or machine learning, right, maybe this talk can sort of help you appreciate what you can do with Python, right? And if you're just getting started on machine learning, or you're thinking whether you should use Python for machine learning, hopefully you can get an idea of how to do that, right? And hopefully I can bring you along in my learning journey for doing machine learning on using Python. Well, if you're a little bit more experienced in the field of machine learning, hopefully this talk will help you sort of understand my own experience and journey with machine learning, right? And if you're using any of those tools, just help you appreciate how machine learning can be used for social good, which is where sort of my motivation for machine learning comes from, right? So to break it down for you, my next few slides are just going to be starting with what is machine learning, right? For anybody who doesn't have a solid idea about it. And talk a little bit more about why I build machine learning on the cloud, right? And then come to a very interesting application of machine learning with, for social good, which is battling deep fakes. It was a thing 2-3 years ago as well, and a lot of efforts have gone into battling deep fakes. And hopefully I can do a little programming session, a live demo, which may be available on your phones as well, to sort of detect deep fakes live over the cloud. So starting with what is machine learning, right? So for somebody who's sort of just getting started, machine learning might seem a little sort of daunting, but at the end of the day, machine learning really is just a lot of mathematical models at the crux of it, right? This image is from a very popular Coursera course from Andrew Ng called Machine Learning Specialization, right? And it goes really deep if you ever want to get started on learning machine learning, just on the basic concepts of it, right? I've personally learned a lot from it, and I highly recommend this course. But well, machine learning, is something you can even do on your laptop. If you think about it, if anybody of you here have done machine learning, you'll know that simple libraries like scikit will usually have CPU compatibility. That means you can run normal regression models on your own laptop. A lot of times you can buy GPUs, right? And you can even run some very complex sort of models on your own desktop or something, or if your laptop has a GPU. But then why do it on the cloud, right? Because doing it on the cloud is not cheap as well, right? Not saying that buying GPUs is cheap, but a lot of times when that machine is not owned by you, you feel like it's expensive. So let me try to help you appreciate why doing it on the cloud sometimes might be simple and sometimes cheaper as well. Think of a machine learning model such as this one, right? This actually is directly from a paper, YOLO, for those who might be sort of well-versed with the object detection field. This is a fairly complex model in the sense it has multiple layers depending on what size of the model you're using. But these kind of object detection models are usually used in applications where you're running it on a robot, for example, where we are doing it in our company, right? And a lot of times these robots or like smaller devices don't really have the compute power on them, right? And that is when you would want to run it on the cloud, given that it's going to run faster over there, right? And actually, YOLO is one such model which is supposed to run real time, given that it has a GPU to it, right? And what it does is it detects a person, or essentially it does bounding box detection, right? But sometimes you have to go beyond even those complex models that might still fit on your GPU, on your own computer, but go more further into heavier models that may not even fit on your GPU anymore. So this is actually directly from a paper as well, from deformable transformers, which is object detection for novel classes that the model has never seen before. So when you have a completely new class that the model has never been trained on, and you only have 10 to 15 images, you use embeddings from the previous classes and try to sort of train the model for newer classes, right, using very little data. Now, these kind of models actually are really, really heavy to an extent that this is the recommended command for running this this training. And the real part that I want you to notice is that it uses 8 GPUs on one computer, right? And actually, that 8 afterwards is because it is using 8 such VMs that are running on that are using 8 GPUs. And the documentation for this paper, the code that comes with this paper, suggested that each of those GPUs is a NVIDIA V100, right, which is already thousands of dollars racking up, right? Whereas if you rent this same kind of machine on GCP, for example, or AWS or Azure, and you're going to run this training for, let's say, even 24 hours, it's going to cost way less than that, right? So hence, doing it on the cloud, doing such kind of trainings on the cloud sometimes makes sense, because setting up such hardware in your own office or in your own house is sometimes just not feasible financially. So if I can sort of get your sort of appreciation on why machine learning is done on the cloud, then finally moving on to machine learning for social good, which is actually very much sort of my motivation behind doing machine learning, right? So actually, this is one of the models that I very closely work with on a day-to-day basis, and it's based on this data set called the Taco data set. It's a data set which is labeled for different kinds of trash, right? And this object detection model, we kind of use it in our company for a very specific purpose, but to help you understand, actually this object detection model for trash can be used for a lot of different use cases, like recycling, trash sorting, tracking and accountability of what brands are making this trash, and so on and so forth, right? So there are a lot of applications of a very simple object detection model for this use case, and we use it for our robot, right? So this robot is actually collecting a lot of trash. This is from Wanchai in Wanchai Basin, right? And this is actually the amount of trash that shows up every day at that basin. And we're not just collecting this trash, but also tracking how much of what kind of trash is there in the water. And and hopefully, give some tracking and accountability so that this trash can be reduced in the water itself in the first place. So simple applications of machine learning can be used for social good, can be used to improve our lives. Now, this is a more sort of serious application, but what I want to do is something a little bit more fun, which is talk a little bit about deepfakes. Has anybody heard of deepfake? Right, a lot of you, right? It was pretty popular. There was a video of the President of the United States giving a speech, and I thought it'd be fun to plug it in here as well. If this video works. I will try to pause it before if there's audio, because not all of it is kind of appropriate. So I'll just pause where. Can there be audio? Or if it's not, then the captions are okay. Right, so here is a, yeah, that would be great if you can get the audio.
Carson is in the sunken.
Okay, I don't want to blast anyone's ears, so I'll reduce the volume first.
In which our enemies can make.
Okay.
We'll try to switch the audio output. Okay.
Yeah. Should be.
It look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place.
I'll just pause here. If you want to kind of watch the video after this, I would not like to play it on stage, but you can go ahead on YouTube and search for "You Won't Believe What Obama Says in This Video." Essentially, this was a problem. I think this video was posted back about 3 to 4 years before, COVID and everything happened. And this had become a big problem, right? So then the problem became, can we use machine learning that was sort of being used to generate these videos to also detect whether these videos are real or fake? And hopefully, and I will not guarantee this, that it might also work on your phones. It's running off my laptop and a few free servers on few places. But if it does work on your phone, I'll be happy. If it doesn't, I'm really sorry. I'll try to demonstrate it on my laptop itself. But before I actually get into the code, I want to talk a little bit about how I've built this. This is not probably the best way of kind of implementing this, but it works. And it's straightforward, right? So we have a browser on the right? And this would be your phone or your laptop, right? And step number 1 is that we need to upload a video somewhere so that it can be processed on. So I'm using AWS S3 here, and uploading the videos that are recorded on the browser up to a bucket. And then at the same time, once that upload is completed, I send a request to a GPU server that I'm running on GCP, I think, right? And this, once I send this request to run a prediction on that video I just uploaded, the server downloads the file from S3 and then returns back a prediction, right? And all of this I've deployed on a Docker image. For the GPU server, it's running on the Docker NVIDIA runtime, and this website is running separately on a Docker image on one of the popular deployment websites I'll show you later. And finally, to bring this together, sort of to build the API, I'll be using something called FastAPI. And I'll only try and demonstrate the server side of things and not the browser side of things, because this is PyCon and we're talking about Python. If anybody does want to know a little bit more about how the JavaScript side of things is done, reach out to me and I can share the code with you. Cool. So let me see if I can just go to the code first. Okay, what is this? I just want to quickly check if my server is still running. Cool, okay, it's all running. I was just playing around with this before coming here. So this website is actually deployed on something called Railway, which is quite a new website. But I'll hide myself first. Okay. Okay, cool. So what this app does is, before I get into the code again, a little bit about what this app does, is it uses the camera here. The idea is, imagine a more real-world application where you could point your camera to an already playing video on a screen and check whether it's a deep fake or not, right? And okay, I think you can see this. So I'd just like to show you a demo and then maybe show you how it's built. Let me see if this works. Okay. It just records a 5-second video and it's going to repeat it, so I'm just going to move it because it's weird for me to see myself. Okay. I hope it works. Give it a little bit. It's kind of uploading the video, slow internet. It says it's 53.91% fake. So it thought that I'm 53% fake. Now, anybody has any guesses what went wrong? Please, go ahead.
One, the camera is on high resolution, and two, you're wearing a mask.
Yes, and that's actually the biggest problem here. The camera is actually, the trained images and videos on this are actually 480p, so the resolution was okay. But actually, I'm wearing a mask, which is a big problem for this model, right? Because when this sort of model was built, it was around 3 to 4 years ago, and as I said, it was before COVID and all happened, so nobody was wearing masks. So it was sort of a biased data set, right? So with my mask on, it says it's 53% fake. I'd encourage you guys, if you know, yeah, sorry, go ahead.
For clarification, I think in most data sets, they don't anticipate you wearing any mask. Because
Exactly.
feedback, it was not meant to use that way if the data is not consideration of it.
Exactly. That's great, right? So again, you can try it yourself when you're in the washroom or something where you're allowed to take off your mask or in your own room, and then I'll share a link to this and I'll keep it up for at least a day or two. After that, I can't afford it, so I'm going to shut it down. But until then, you can give it a try, right? So that's the idea. Cool. So let me pull up the code to show you a little bit about how it's built. Okay. No secrets, nothing? Okay, cool. So as I said, I'm using FastAPI to build this. It's a little bit of these things I've sort of refactored out, so you don't see a lot of the complex model building things, and that's usually not the point, but let me do this. So actually, I'm connected to a GPU server. You see on the bottom here, it's a remote connection. This is using one of the servers that I have built somewhere here. So this is actually one of these servers. right? So it's like a small GPU instance which is deployed on GCP, right? And you can connect to it and stuff. Where is it? Cool. So just let me try and walk you through this code. So we import some very basic stuff like FastAPI, right? And we create an application out of it. We are going to download images from download videos from S3. So we import Border 3 for S3 side of things. And these are some of the model tools that I sort of just compiled together, right? Which is here. It's a little more ugly looking, but it's essentially loading a bunch of these weight files and running an evaluation on them. Sorry, not here. Running an evaluation on them, right? But here, I don't know if you guys have worked with, if you all have worked with, web applications, but CORS is usually an issue. Don't do this on your production applications because you're basically allowing everybody to request your API. But for this purpose of this demo, I guess. And then I'm expecting a request from the client, calling it a video request. And all I'm going to take from the browser is a file name, because the file has already been directly uploaded to S3, right? So I don't need to really stream the whole file over the HTTP network. I just need the file name that I'll download later. Cool. So I make two routes. One is to check before coming on stage whether my application is running or not. So just to check whether it's working. And whoa, this is very buggy. And the second one is predict, which basically runs the actual prediction. And you'll see in this predict step, there are just four. In this predict function, there are just four basic steps. One is download the actual file, right? Which I'm going to get from the request, right, with the file name. And then run a prediction on it using the model that is hidden away in the other files, right? And then just log the prediction here. So when I ran last time, you see the prediction was 0.539, right? So that's running the prediction and logging it, and then just returning a result back to the user, right? And that's what you see on the browser screen with prediction and so percent. And going a little bit deep into how you download the file. So as I said, the browser side of things, I can make the code available. It's pretty straightforward after this talk. But once the file has been uploaded, actually downloading the file to the server is straightforward. You just create a S3 client, give it some credentials, and then after that, give it a download path, right? So I'm going to download it in a very specific path here, right? And you'll see that all the files that I download are actually going to show up here, right? So as we process them, this is actually one of the storages on GCP, and I'm just dumping them all there. So it's available on the cloud as well. And then I just download this file using the S3 client or download file. I'm sorry. And I return the download path so that I can run a prediction on that. Running a prediction is simple as setting up a few parameters, frames per video, that you want to start doing some prediction on. Extract the face, so this deepfake runs on faces, right? So if you put up actually something else in front of it, it will not work, right? Like I don't know, a sheep or something, right? It won't work. And then there's a very simple handy function that I've built called predict on video that takes these things and just runs on the video, runs the prediction on the video and returns a value. So yeah, I think this is as simple of a walkthrough as it gets. I've shown you the demo already. If you want the link to the demo itself, you can find it on my GitHub profile. Actually, it's public, I believe. And if it's not, please do reach out to me. Right. And that sort of wraps up my talk. Thank you so much for listening. This is our company, Deploifai. You can scan the QR code and use the platform that I use to spin up the GPU servers and stuff. We are basically available for free at the moment, right? So you can create an account, log in with GitHub, and just create as many servers and stuff as you like. Thank you so much for listening.
Sure, guys. We got some questions for you, Utkarsh.
Okay, so thank you for demonstrating the the API server in FastAPI, and I
Thank you.
believe that FastAPI is more production ready than Flask, and it is
Right.
better than Django. But I have found some flaws, like something that it may be can be used so that the performance of the server can be better. So can we go back to your code?
Oh, yeah, sure.
Okay. So one thing that concerns me is that in the predict endpoint, so the download file is actually a synchronous version of downloading. So I think because when you run async, then you only have one thread and running in the event loop. So the download file, I'm not sure whether it is blocking or not. So is it better to make the predict into not async def, but just a synchronous version? Or maybe we can use the AI Boto 3, the asynchronous version of the Boto 3 client so
For sure.
that we can increase the performance?
Sure, that's a great question. So actually, the download here is a blocking request, right? So this download file function is actually going to block the rest of the process from happening. So that's why I said that if you guys actually give it a try right now, and when I'm trying it, it's gonna actually block your request from coming in, right? And it's valid that this code actually could be improved by making this process asynchronous. If you would like to hear my take on it, I would probably just add another route here, because I still would need a route requesting to run the prediction on a file. That means downloading a file and generating a result on it. But then I could keep that result here on the server, and when the user sort of polls on prediction result or something, and just and I could just simply return something else, so saying, right? I could make something as simple as that, so that when the user keeps polling on this result, obviously this is also not an ideal version of this, but I would just split this into two requests to make things more asynchronous, so that one of them is a job sort of request, and the other one is a polling request to ask for the prediction result, right?
Thank you.
Something like that.
So do we have any more questions for Mr. Utkarsh? Please raise your hand.
What video formats are supported?
Actually, this one is just supporting MP4. I squeezed in some time to build up this demo, so at the moment I just have MP4s on there. But it's really versatile in the sense that on the browser side of things, if you upload multiple formats, it should work just as well.
I noticed that you're using VS Code Remote to SSH into a server. Is
Yeah.
that the same server that's actually the model is deployed on? Because I also see some logs here. So could you expand more on the architecture of this demo?
Yeah, for sure, for sure. So maybe I'll just close this remote connection first. Thank you so much for the question. It allows me to demo a little bit more about this. So I actually have a VS Code extension that is built alongside with Deploifai. And you can, so I'm using this workspace, and I can just connect to the server, right? So it's like a direct connection, SSH connection to that server. Now on that server, yes, it's the same server that has deployed the machine learning model as well, because I developed the model on this and then trained it and then deployed it using Docker. So to actually make a deployed version of this application, I used a Docker file, and it's running in the Docker runtime of the server itself, right? So the actual setup of Docker, for those who are not familiar, you have to provide a base image, right? We're using the PyTorch runtime image, which has qdyn enabled, right? Because we have a GPU server, we can actually run it in the NVIDIA runtime, right? And install some basic dependencies to run, video processing, and some of the weights that are needed to run this model. And then I just installed FastAPI, OpenCV headless, because we need it for processing videos, and some other libraries, including Bodo3 and FaceNet, which are required for my code, right? And then I have a run script which runs when this Docker container sort of starts up. And it's as simple as just starting a UVcorn app, which is a HTTP middleware sort of server that allows me to accept requests, right? And yeah, all of this is built on a Docker image which is running here. I can give it a go. So it's running as this. I call it API runtime, and if I give this a go, so these are the logs from our demo. So if you actually open up, this website, actually I realize that the URL of it is pretty long, but I'll just do it here in the background. So I'll just run this prediction again. A new sort of post request shows up, and it's going to take its time to run the actual prediction and then return back the result. I hope that makes things clear. I'm sorry, it's going to take a bit. Yeah, there you go. So,
Can I
other
ask a
questions?
question? Sorry. Here. Sorry.
Yes.
So can you explain a bit more how the data set, what kind of data set you use to train this deepfake detector?
For sure.
Yeah.
Well, that's a good question. So actually, it's from this challenge from Kaggle. Let me see if I can pull this up. Kaggle D. This one. This was a couple of years ago, actually, the challenge itself. It was launched 3 years ago and provided about 400 gigabytes of videos, which is here, right? So I'm not sure what the right thing to do here would be, but I would not pull up any videos from this data set because I'm sure there are some policies around actually sharing this data publicly, but this is the source. You can go ahead yourself, enroll into this Kaggle challenge even now, and you get access to this data, right? And yeah, there are many approaches actually to solving this challenge as well, and you can look at how these people have trained this model for themselves and generate the same results on your own computer and whatnot.
And do you know what kind of feature the model is looking at to classify?
Yeah, sure. Let me see if I can pull that up. So this is actually not my code. I'm not an ML scientist. I'm more like an engineer. So I take other people's code and get it to run. But I kind of looked through a little bit of what this person is using to detect deep fakes, right? And I found some really interesting sort of segmentations that these models are doing to get those features out for deepfake detection, right? So some things that are common deepfake will have, they will have deformities around the face, around the eyes, because those are very difficult to imitate for a machine learning model. So you segment those kind of features out from the face after you detect the face itself, right? And then sort of try to see if you can spot patterns in the deformities that common machine learning algorithms will generate while generating a deepfake video, right? And so as you can see here, like there are segmentations around the eyes, especially the harder parts, the nose, right, and that sort of stuff. And a lot of times, the lips won't be in sync, right? That's why they try to hide, or the eyes might not be in sync, so they try to hide the eyes, segment that out, and see if the face is in sync with the video and audio. And similarly, different parts of the face, whether eyes and lips, sort of facial expressions are consistent or not. So that's the thought process behind it. The model itself has some more depth to it, but that's sort of the on top of all of this. Yeah.
Thank you. Thank you. Any other questions from the floor?
Thanks for your presentation.
Thank you.
So when it comes to productionalizing machine learning application, so for sure we could deploy to cloud, but we could also deploy to edge devices, like
Right.
the robot that you are currently building.
Right.
So what would be the considerations picking like two paths?
That's a great question. So that's something actually I struggle with on a day-to-day basis, which is understanding when to deploy on the edge and when to deploy on the cloud, right? So firstly, starting with a few challenges of deploying on the edge, right? You have a few edge devices that you can sort of deploy to and are capable of running machine learning models. So a very common one would be these NVIDIA Jetson boards, right? So these are like these tiny little chips that can actually fit on a robot and have some fair amount of GPU compute power, right? But there's a limitation to it, which is that they really heat up during operation, right? Especially if you throw a really complex model at them, anywhere between 80, 85 degrees Celsius on our robots, especially because they're sitting outside under the heat in the ocean, right? And they usually shut off and are not as reliable as you would want them to be, right? So that's one sort of drawback behind edge computing, especially for machine learning, right? But that being said, obviously you reduce latency. So there are some lighter models. For example, I talked about YOLO, right? And that is actually, these Jetson boards are actually fairly sort of capable of running those YOLO models. And YOLO runs, sort of live, a real-time detection model, right? So, for example, our robot uses a sort of real-time variation of YOLO to detect objects in front of it, right? And that's something we can't afford to do on the cloud because we need to give that feedback loop to the robot, right? But then a lot of that tracking and accountability where we have to go into the details of the trash, detect what kind it was, what are the brand stickers on it, and so on and so forth. We use a more complex model. So we also at the same time upload those videos and photos to the cloud and run a heavier model on it, which is a variation of the RCNN models. And that's how we try to divide things up. So, I mean, the drawback with cloud would be that, sometimes you get high latency, you need an internet connection and things like that. But usually for running very heavy models and applications, we just try to offload it to the cloud.
Any more questions for him? If not, then I guess that's pretty much for this session. And thank you, Mr. Utkarsh.
Thank you.
So we got 15 minutes break for now, and then our next section we will start at 3:45. 45. Thanks.